All right, so now we'll move on to the next part of our lesson. So we will be discussing now about conditional probability. Okay, so what is conditional probability? Okay, so the probability of an event can change depending on the outcome of a previous event. Okay, so let's see what's going on here. So for example, the probability of you being late for work may change depending on whether or not you oversleep. So situations like this can be modeled using conditional probability. You can use a vertical line symbol. Okay, so a vertical line is used to indicate the conditional probability. All right, guys. So this is a really important topic. Okay, so the probability that B occurs given that A has already occurred is written as P given A. Can you guys see this? So this is an important notation. Probability, you write here B, the line, the vertical line, and then you write A. So basically, whenever you see something like this, this means conditional. Okay, so this means it's conditional. What do you mean by conditional? So, I mean, the event A here, the event that is written after the vertical line. Okay, the event that is written after the vertical line, it has already happened. Okay, so it has already happened. So you're supposed to find the probability of B happening, given that all A has already happened. So maybe the probability of you being late for work may change depending on whether or not you oversleep. So if you so basically one event, let's say you overslept, so then event here has already happened. Then what's the probability that you will be late for work? Okay, so basically one event has already happened. So given that this event has happened, what's the probability of the other event happening? Okay. Okay, so then so this is a really important case, and then we are discussing it for independent events. Okay, probability of A given B or is equal to probability of A given B dash is equal to probability of A. Okay, what is this? Okay, so we'll talk about it. So they are saying if events are independent, now what do you mean by independent events? You know, independent depends, they don't depend on each other, right? So independent events, if you have two events A and B, A happens regardless whether B happens, right? B happens regardless whether A happens. So if you try to get the probability of A given B, now you know this is conditional probability. Now in this case, if events A and B are independent, okay, so here your events are independent. A and B are the events. Okay, so this is a different situation. Okay, so now we're talking about different situations. So let's say our events A and B are independent, which means it doesn't affect. Okay, the probability of A happening has no dependency on B. B happening has no dependency on A. So now they are asking you to find the probability of A given that B has happened. Now they are saying B has happened. So what's the probability of A happening? So what do you have to say here? So what do you have to say here? You know, the probability of A happening, if events are independent, the probability of A happening does not depend on B. Why? Because they are independent. Are you with me? So because of that, if the events are independent, the probability of A given B is simply equal to probability of A. Why is that? Because A doesn't depend on B. So regardless whether B happens, or regardless whether B doesn't happen, even if B is not happening, the probability of A happening is the same. It doesn't depend on me. That's why we write here probability A given B dash. Now what is B dash? B dash means B is not happening. So given that, so we know that B is not happening. Okay, the event after the dash, we know the outcome. So after the dash here, B dash means B doesn't happen. So what's the probability of A happening? So if the events are independent, regardless whether B happens or whether B doesn't happen, it doesn't affect A. So therefore, the probability of A is not affected. Can you guys see why what's going on here? Okay, so it doesn't affect A. Okay, what if I write it to the other side? Okay, so what if I write it to the other side? Probability B given me. Right, this is really important that you understand what happens when you switch the order. So when probability B given A means what? Always remember the given event is after the slash. So after the slash, you have A. So if after the slash, if you are having A, it means A has already happened. Okay, so if A has already happened, what's the probability that B is happening? So as I told you, if the events are independent, even though whether A is happening or if A is not happening, it makes no effect on B. Therefore, the probability of B given A is what? Probability of B given A is equal to probability of B. Do you understand? Now, because the second event A has happened. So we are talking about, we are trying to find the probability of this other event, the first one. Always you try to find the probability of the first event, given that the second one has happened or not happened, depending on what they give. Now over here, the second event is A has happened. So what's the probability? If A has happened, what's the probability of B happening? So over here, it directly goes to probability B because B doesn't depend on A. Why? Because they are independent. Now remember, all these special rules are for independent. Okay. Then there's another one we can write here, right? Probability of B given A dash. So what is this? The probability of B happening. What is the probability that B happens? Given A doesn't happen. So the event A doesn't take place. We don't get the outcome A. But what's the probability of event B happening? So once again, if the events are independent, the probability of B doesn't depend whether A is happening or it doesn't happen. It does not make any impact to B. So therefore, it's just probability of B. So guys, these are some important rules. But remember, these rules are only and only applicable if the events are independent. By the way, if there is any dependency, you can't go with this. Okay, so if A and B depend on each other, you can't write this. Then in that case, we'll have to find another way to get it done. Okay, so at this point, we are talking about independent events, but we will be discussing how to get these kinds of conditional probabilities when there is a dependence, because there are cases where event A and event B depend. You will have questions like that. So that we will discuss in the we will discuss it soon in the next part of the lesson. So right now, we'll practice with this. Okay. Okay, so then you can use this condition to determine independence. Okay, so they are saying if events are independent, this particular condition must be satisfied. Okay. All right, guys. So over here, I have just written down the way you read this. Okay, so it's really important that you read it correctly. So over here, I have written this is the probability of B given A, and over here, I have written this is the probability of A given B. Okay, so you need to be able to read them correctly. Okay, so we'll move on to some questions and practice with this. All right, guys. So let's move on to exercise 4E and then the question. So in this exercise, first we will learn how to actually find this kind of a conditional probability. Okay. So they say here the two-way table shows the fast food preference of 60 students in a school. Okay, so you have here a two-way table. So on the columns, you can see that it shows pizza, curry. So those are two options of food, and the other one on the rows, you have year 10, year 11. So you have basically 2 years of students. Okay, so in this two-way table, one shows how the pizza is preferred by the students and how curry is preferred by the students. And the other way, if you check the rows, you can see how year 10 students prefer the food and how year 11 students prefer their food. Can you see the two-way table and how it's done? All right. So they are asking you to find the probability of probability table of getting a year 10 student. Okay. So what's the probability of getting a year 10 student? So all you have to do here is year 10, right? So go through year 10. So this is year 10. So you can see the total of year 10. Can you see in this row? Okay. So the total of year 10 is 29. Can you see? So that means in in year 10, there are a total of 29 students. In year 11, there's a total of 31. So altogether 29 plus 31, there's a group of 60 students in this school. I didn't say it over here as well, right? So what's the probability of selecting a year 10 student? You have 29 students out of 60. So that's a simple probability, right? So you write the amount that you require out of the total amount. That's the simple way of writing probability. All right. Okay. So part B, probability of curry given year 10. Okay. Now this is really important. Okay. So we are learning how to write a conditional probability now. Okay. So now here they don't talk anything about independence. So they don't say anything like that. So you just need to find the probability on your own. So let's find the probability on our own. So right now what they say here is always remember the second event. The event after the vertical line is the given one. So this is given to you. So this is given means this event has already happened. So given that this event has already happened, what's the probability of this happening? So now you need to understand that you are going to take this probability from this group because you are going to now be focused on the given set. So year 10, you're only be going to considering year 10, not the whole set because it's conditional probability, it's condition. So you will only be considering from the given set. From the given set, what's the probability of this happening? So what's the given set? Year 10. So in year 10, what's the total? In year 10, you have a total of 29, which is going to be your denominator. Year 10 is going to be your denominator. All right, and then what you do here is write the numerator. So the numerator, the probability of curry should be taken from the year 10 students, not from the whole population. Okay, so we are only going to be considering the year 10 students. So from the year 10 students, you can see this is the row concerning year 10. Can you see? So from these year 10 students, how many of them prefer curry? So you can see from this, there are 18 from the year 10 students, 18 of them prefer curry. So you can write 18 on top. And this is the conditional probability. So probability of curry given the year 10 student. So year 10 student probability at the bottom, because that's your whole, that's the thing that you're considering. And out of those students, how many like curry? All right. We'll try another one. I think in part C, this needs to, they have written the same sum again. So let's correct that. This should be the probability of year 10 given curry. So just correct that. Okay, so this should change positions. Okay. Okay, so part B and part C, they're looking the same. So I changed the question to make sense. All right, so now what's given in the conditional probability? Now curry is the given, it's the given event. Can you see? So what's the probability of getting a year 10 students given that they have curry? So now curry is the given event. So in that case, now you consider, can you see? So you now go with curry. So that means the given event is curry. So how many of the people totally like this particular, like this particular food preference? I mean, how many of them have this particular food preference? So curry, the total is 35. Can you see? So now you look into this because this is the given event. So for curry, you have 35 students who prefer that. And from that 35, okay, from that 35, remember now we are not going for the whole population. From this 35 students, how many are there in year 10? So out of this 35, this 35 is made from 18 year 10 students and 17 year 11 students. All right. So we can see 18 of them are year 10. So this is the conditional probability. Do you see how it's done? All right. So you can attempt part D on your own now. All right, so part D, I'll do it now. Probability of pizza given year 11. So year 11 is the one that's given to you. So in year 11, the total of year 11 is 31. So out of that 31, out of this 31, 14 prefer pizza, 17 prefer curry. So we are supposed to get the probability of pizza, that's 14. All right, so you can see how we work with conditional probabilities now. All right, so let's move on to some more questions. All right, so next we'll move on to question number 4. Okay, they say a red and a blue spinner each have 4 equally likely outcomes. Okay, numbered 1 to 4. So there are 2 spinners, each of them have numbers 1 to 4. So all the numbers are equally likely. Okay. The 2 spinners are spun at the same time and the sum of the numbers shown X is recorded. Draw a sample space diagram for X. Okay, so you have to draw a sample space. Okay, so let's draw a sample space, basically a table showing all the outcomes, right? So it should show the outcomes of spinner, of the red spinner, and it should show the outcomes of the blue spinner, and then it should give you the totals also, right? So you guys know how to create the sample space. All right, so let's create it. So make a table. So the outcomes are 1, 2, 3, fourth. So let's say this is the blue spinner. So red spinner. Out comes 1, 2, 3, and 4, right? All right, so here we have the blue spinner and the red spinner. Okay, so now let's write the outcomes. So what are they saying about the outcome? They are saying the outcome, what we consider is the total. Okay, so X is the sum of the numbers. So basically over here, the first outcome is if the blue spinner shows 1 and the red spinner shows 1. So this is the first one. So if blue and red both show 1 and 1, so you are supposed to worry. Our variable is the total. Okay, because the sum of the numbers, that's what we are interested. So always read the question because it might be different. Okay, question to question, they might say it's the sum, it's the product, it's the difference, it's twice. I mean, they will say different rules. So read the question and make the table according to the rule that they give you. So here the rule is to sum the numbers. Okay, so the first outcome is when the blue spinner gives 1 and the red spinner gives 1, right? You can see, which means the sum is 2. Agreed. Here 2 plus 1, 3. Here 3 plus 1, 4. Here 4 plus 1, 5. This is 3, 4, 5, and 6. This is 4, 5, 6, 7. This is 5, 6, 7, and 8. Can you guys see? Let's just separate these two, guys. All right, can you guys see? I'm trying to separate these two, guys. So these are the outcomes of the spinners. I mean, and these are the sums, the individual sum for every possible outcome. Okay, so for all the possible outcomes, we have the this particular set of, I mean, the sums, the set of sums, possible sums. Okay. Okay, so this is the sample space. All right, so part B, Roman number 1, they are asking you to find the probability that x equals 5. Probability that x equals 5. So guys, let's look at this table and check how many positions are there where x is equal to 5. So guys, over here, now here, these are the x outcomes, the ones I have written in green. So how many outcomes are there that gives us 5? I think you can see there's a whole, I mean, you can see there's many, right? So over here, 4 plus 1, 3 plus 2, 2 plus 3, and 1 plus 4. So we can see that this entire set of outcomes. So how many outcomes are there? A total of 1, 2, 3, 4. We can see in this table, we find there are 4 5s, 4 of them. There's 4 of them. So you have 4 of them out of how much? Out of total. So what's the total number of outcomes? So this is a table with 16 outcomes. Can you see? 1, 2, 3, 4, 4 times 4. There are 16 outcomes in this table. So out of 16 possible outcomes, 5 appears in 4 of them. Out of 16 possible outcomes, the outcome 5 appears in 4 out of 16. So that's why it's 4 over 16, which simplifies to give you 1 over 4, right? Roman number 2, the probability that x is equal to 3 given the red spinner is 2. Okay, guys, so look at this. Okay, now this is important. The probability, so now here you can see it's conditional probability. Why is it conditioned? Because I mean, you can see they have drawn the vertical line and they are conditioning it. So remember, when they're giving you a condition, you have to always take your probability with respect to the given event. So with respect to the given event. So red spinner is 2. So which means that's what you're going to be considering as the full set now. So red spinner is 2. I think you can see red spinner is 2 is this one. So which means I'm only considering this row. I don't have everyone at my, I can't go with everyone now. Okay, so the probability that the red spinner is 2. So you can see red spinner is 2. We have how many outcomes? When the red, to make the red spinner give 2, there are only 4 possible outcomes. So the total number of outcomes we have here is 4, not 16 now, because we don't have the whole sample space. We only have the given sample space. So red spinner is 2. In that sample space, there are only 4 outcomes. So out of those 4 outcomes, from those 4, what's the probability x equal 3? So x equal 3 you have in how many outcomes? You can see x is 3 in just one outcome. So therefore you write here 1. X is 3 in one of them. So the answer is 1 over 4. All right, guys, can you see how it's done? All right, moving on to Roman number 3. So probability blue spinner. Blue spinner is 3 given x equals 5. Okay, so remember when they give you the given, always check. So first we'll go for the given that, because that's what we require. Okay, so what's the given that probability? X is 5. Okay, so let's take all the given events. So the given events are the ones where x is 5. Okay, how many such events are there? I can see, let me mark in blue. So this is the given event. Can you see the ones I'm marking in blue? These are all the 5s we have, right? Do we have any other 5s anywhere else? No. These are all the 5s. These are all the x equal 5. Can you see? So there are how many of them? 1, 2, 3, 4. There are 4 of them. X equals 5 in 4 places. So from those, from out of those 4 possible outcomes, where x is 5, what's the probability that the blue spinner is a 3? Okay, so now you have to check the blue spinner. So out of these, out of the events I've circled here in blue, the given event, how many of them make the blue spinner give a 3? So look at this first one. The first event I have circled here is 5. In this, the blue spinner is 1. Can you guys see? Over here, the blue, from this 5, the blue spinner is a 1. That doesn't work. From this 5, the blue spinner is a 2. That doesn't work. Okay, from this 5, the blue spinner is a 3. That works. This works, right? And this, from this 5, blue spinner is a 4. That doesn't work. So from the events where x is 5, which I have circled, from those 5s, which one makes the blue spinner 3? So you can see there's only one 5, only one outcome who can make the blue spinner 3. So therefore there is only one outcome. So probability is 1 over 4. Okay, is that clear? All right. All right, guys, we'll move on to question number 9. A hiking group is made up of 63 women and 47 men. 26 of the women and 18 of the men use a walking stick. Draw a two-way table to show this information. All right, so let's draw the table. So a hiking group is made up of 63 women. Okay, so you can make the table. So basically, the way you choose rows and columns makes no impact here. Okay, so if I put women and men into the columns, or you can even put women and men into rows, there's absolutely no problem. Okay, if you change that. So women and men are the first group. What about the other one? Now for the two-way table, we need a column and we need rows. So who are the rows? So they say 26 of the women and 18 of the men use a walking stick. So out of the 63 women, 26 use a walking stick. So we can say, so then women, and here the ones who use a stick. So then what should automatically be the other one? So automatically out of 63, 27 use a 20, if 26 use a stick, the remaining amount doesn't use a stick, right? Non-stick, okay, you say not using a stick or no stick. All right, does this make sense? And you will have to make it extra because we are going to go for the total as well, right? Okay, so we have the total here as well. In these kinds of tables, you have to go for the total. All right. So women, 63 women are there in total. So in total, there's 63 women. Okay, and 47 men. So 63 plus 47, get the full total. 63 plus 47, we have 110 altogether in the full group. Can you guys see? So fill everything. The total of men and women, the total group is 110. Okay. So out of that, they say, okay, so from 63 women and 47 men, 26 of the women and 18 of the men use a walking stick. Okay, 26 of the women use a walking stick and 18 of the men use a walking stick. So now you can see how many women don't use the walking stick, because out of 63, if 26 use the walking stick, then 63 minus 26 is the number of women who do not use the walking stick, right? So from 56, so from 63, you subtract 26 and you get the answer here, 37, right? Agreed? And again, out of 47 men, 18 use a walking stick. So 47, you subtract 18. From 47, when you subtract 18, you get 29 men do not use a walking stick. Great. Okay. Now let's get the total. So how many people use the stick? So you have 26 women and 18 men, add them together, and you have a group of 44 who use the stick, and then who doesn't use the stick, 37 plus 29. 37 plus 29 is 66. You guys are with me? So this is the two-way table, the answer for part A. Okay, so you make the two-way table. Now we'll move on to part B. Roman number 1. One hiker is chosen at random. Find the probability. Use as a stick. The probability of using a stick. Guys, what's the probability of using a stick? So we can see here, now here there's no conditioning. So which means the entire group, the entire population is considered here, the entire group. So here, when it comes to the stick, how many people use a stick? There are 44 who use a stick out of 110. Okay. Roman number 2, probability uses a stick given female. Okay, so this is conditional probability. So now we have to consider what the given that part is female. So you take all the females. How many females are there? How many women are there? Total women or total females, we have 63. So out of the group of 63, from the female group, okay, given that it's female, how many are there who use a stick? So from the female group, 26 use a walking stick. Okay, from this group, from the women, that's 26. Roman number 3, probability of male given using a stick. So now you need to consider the group. The main group here is the people who use the walking stick. Okay, so the people who use the walking stick is this. So you have to now consider, according to what I have drawn, the row. So this is the people who use a stick. So we have a total of 44 who use a stick. So out of that 44, out of this 44, what's the probability that a male uses a stick? So we have 18 males in this group of 44 who uses a stick. So we write here 18 out of 44. All right, guys, is this clear? Okay, so I hope this
Yes,
part, the
teacher.
two-way tables are clear to everyone.